Okay.
Good morning, dear teachers and dear examiners. Welcome you all. Today, we are about to present you with our project Periodic Table and Trends. I am Upani and my team members are Dharani, Minuli, Inupama, Nethmi, Vihanga, Vihal and Kavisha. The content we are supposed to do is about the history of periodic table, the periodic table, first ionization energy, electron affinity, electronegativity, atomic radius, valency, melting points, and boiling points. So, I would like to invite Minuli and Vihal to describe about the history of periodic table.
Thank you, Upani. When we consider about the history of periodic table, Russian chemist Dmitry Mendeleev started the development of the periodic table, arranging chemical elements by atomic mass. Here you can see the modern periodic table. It consists of 118 elements. Those elements are classified into few groups.
The elements highlighted in red are called alkali metals, alkaline earth metals in orange, transition metals in yellow, nonmetals in purple, halogens in pink, and noble gases in brown.
Yes, Vihal, can you describe few more details about periodic table?
Sure, Minuli. Furthermore, based on the entry of valence electrons in the respective subshell, the periodic table is divided into S, P, D, and F block. The diagram in the slides gives you a clear idea about it. When we talk about the modern periodic law, it states that the physical and chemical properties of the elements are the periodic functions of their atomic number. Also, scientists arranged elements in increasing order of atomic numbers from left to right across each row and discovered elements having similar properties repeat after regular intervals.
Thank you, Vihal. So let's give our attention to groups and periods of periodic table. We have 18 groups in the modern periodic table. So what are groups?
Groups are the vertical columns in modern or long form of the periodic table.
Yes, Vihal, and it is important to state that each group consists of elements having same outer shell electronic configuration.
Okay, then what are called periods?
Basically, we have 7 periods in the modern periodic table, and periods are the horizontal rows.
Also, each period represents the number of energy levels present in an atom of an element.
Okay, that's a summary on periodic table. Now, I would like to invite Upani to talk about periodic trends.
Yes, thank you, Minoli. So first we would describe about an important periodic trend which is called ionization energy. First, ionization energy means the minimum energy required to remove 1 mole of electrons from a gaseous state atom to form an unipositive ion. The given three equations show how first, second, and third ionization energy happens. So now let's move towards the variation of first ionization energy. First ionization energy decreases downwards the group. That's because when moving downward the group, number of energy levels increase, so the gap between final energy level and the nucleus increase. So the first ionization energy decreases. Also, when moving across a period, first ionization energy increases. That is because when moving along a period, the number of protons increase and the nuclear charge increase. So now I would like to hand over to Dharani to continue.
Thank you, Upani. So when we consider the variation of first ionization energy, Though it increases in a zigzag pattern, there are some variations. The graph in the slide shows ionization energy of oxygen is less than ionization energy of nitrogen. That's because nitrogen have half-filled orbitals which are extra stabilized. So energy required to remove energy required to remove an extra stabilized atom is much greater. That is the reason for the few exceptions in first ionization energy graph, though it increases in a zigzag pattern. Now let's turn towards second ionization energy, the minimum energy required to remove 1 mole of electron from a gaseous unipositive ion to form a dipositive ion. Also, it is important to note that second ionization energy is always greater than first ionization energy. Now let's turn towards Netni and Kavisha. Okay, what do you know?
We would like to describe about the electron affinity. Electron affinity of an atom or molecule is the amount of energy released when an electron is attached to the neutral atom or molecule in gaseous. Kavisha, what about the electron affinity value?
Most elements have negative first electron affinity values. Few examples are hydrogen and lithium. Also, few elements have positive endothermic first electron values. Nitrogen and beryllium are the best examples for it. Second, and it is important to note that second electron affinity for all the elements are positive. This video will explain more details about electron affinity.
In a period, electron affinity increases from left to right. Exception occurs in case of carbon and nitrogen. Carbon has greater electron affinity than nitrogen because in nitrogen has more stable half-filled valence shell electronic configuration. In a group, electron affinity decreases from top to bottom. Exception to this rule occurs between fluorine and chlorine. Fluorine, due to its smaller size, has high electron density, resulting in a slightly smaller electron affinity than chlorine. In a period, electron affinity.
It's time to talk about electronegativity. Electronegativity is the ability of an element to attract bond electrons in a molecule toward itself. Depending on electronegativity, there are two types of bonds. They are polar covalent bonds and non-polar covalent bonds. A polar covalent bond is a bond between two nonmetal atoms which have different electronegativities. As you can see here, the chlorine atom and the hydrogen atom unequally share their bonding electron pair. A non-polar covalent bond is a bond between two nonmetal atoms which have the same electronegativity. In here, the two hydrogen atoms share their bonding electron pair equally. Let's see the variation of the electronegativity values according to Pauling scale. Across the period from left to right, electronegativity increases as the nuclear charge increases across the period, and downward the group, electronegativity decreases as the attraction between the nucleus and the last energy level decreases. Fluorine is the element which has the highest electronegativity value. There are three factors we should consider when we determine the electronegativity of an element. They are hybridization, charge, and the oxidation number.
So, Uma, can you describe how above three factors varies with the electronegativity?
Upani, it's easy to memorize how these factors varied from the S character hybridization and the positive charge and the positive oxidation number, as when these factors increases, the electronegativity also increases and vice versa. Now I'll hand over to Vihanga to talk about atomic radius.
Thank you, Inuvama. Atomic radius is a measure of the size of its atom. Mainly, there are four types of radius. They are covalent radius, van der Waals radius, metallic radius, and ionic radius. In ionic radius, when positive charge of atom increase, radius decrease. For an example, radius of sodium plus iron is less than sodium atom. When negative charge of atom increase, radius also increase. For an example, radius of oxygen atom is less than oxygen 2 minus iron. In an isoelectronic series, nuclear charge increase in order of increasing atomic numbers, so radius decrease. Next, Nithmi is ready to explain about valency.
Valency can be defined as the combining power of an element with atoms of same element or different elements. For an example, number of valence electrons in carbon is equal to 4. Therefore, the valency of carbon atom is also 4. If number of valence electron is equal or less than 4, valency is equal to the valence electron. If number of valence electrons is greater than 4, valency equals 8 minus number of electrons. Another important point is elements in same group have same valency. For an example, all elements in group 1 have same valency. Hydrogen, lithium, sodium, potassium, rubidium are same. Now, Dharani, it's your turn.
Thank you, Nitin. Melting point of a substance is the temperature at which it solid to liquid. As an example, melting point of ice is 0 degrees Celsius. Boiling point means the temperature at which a liquid boils and turns to vapor. As an example, boiling point of water is 100 degrees Celsius. For group 1 and 2, boiling point and melting point decreases as moving down the group. For transition metals, they mostly increase as moving down the group.
Hope our presentation was clear to you all and informative to know more details on our topic, periodic table and trends. So, on behalf of my team, I would like to thank you all for being a wonderful audience. Thank you.
Okay, you can share your performance. Okay. Thank you very much. Okay, for that session. Now the question session will be on. Now our examiners can ask questions. Please move to your slideshow. Please move to your slideshow. So you presented about the period trends and the period table. So related to the period table and period trends, your presentation was on. So you have presented about that. Okay. So please ask the questions. Shavindya, can you start?
Yes, sir. Now I'd like to ask this question relating on electron affinity. I saw that in your presentation. As you know, the highest electron affinity is showed by chlorine in the periodic table. So my question is, why does chlorine show the highest electron affinity related to, now even there's fluorine on top of chlorine in the halogen table. So why is chlorine having a higher electron affinity than fluorine? You can give a small described answer related to the shape of the molecule and the orbitals. Thank you.
Okay. So who is willing to give the answer? Dear students, you can give your answer. So try to take time and give you the answer. Best one. Okay. Yes, Upani, please voluntarily join. We don't name any students. Okay. So you can ask. You can just answer the question. So why chlorine is more electronegative compared to fluorine? That type of a question. So for this question session, you'll be getting 5 marks. Okay. Please try to keep your marks.
Means the energy change that occurs when an electron is added to a gaseous state atom. So chlorine has the first electron affinity minus 328, and chlorine it is minus 349. When moving downwards the group, electron affinity decreases, and it is a negative value. So chlorine is below fluorine in periodic table.
Okay, I think we didn't get the answer well. So shall we move to the next question also? Yes, Pinsara?
Yeah, you said that ionization energy varies across the period from left to right and top to bottom. I want to know what is the base behind that principle, behind it.
Sure, teacher. So when ionization energy decreases downwards the group, that is because when moving downward, the number of energy levels increases. So the gap between final energy level and the nucleus increases. So the energy required to remove an atom is less. When moving across a period, number of protons increases, so the nuclear charge increase, so it is difficult to remove an electron from the atom. We should give more energy to remove an electron from the atom. So ionization energy increases across a period.
Yes, Pinsara? Are you satisfied with that answer?
Yes, sir. Yes, that was okay.
Yeah, okay, with the answer. Yes, shielding effect also affects the ionization energy, shielding effect radius. Okay, I think, yes, next question, Sajita. Yes. Yes, we can hear you, Sajita.
Yes, dear student, your topic is periodic table and trends. We find your topic in our lesson number 1, atomic structure. You all talked several trends found in periodic table. So my question is based on electron gain energy, right? So I shared a slide with question. Hope you all can see my slide.
Yes, yes, it's clear.
For most atoms, electron gain energy is negative, but there are few atoms like beryllium and nitrogen, they have positive electron gain energies. So what would be the reason for that? Here I have shown you the electron gain values for relative atoms also. So this question is very simple. Just give me a reason for having positive electron gaining energy for nitrogen and beryllium.
Okay, please, students, you can answer the question.
You don't need to be hurry. Take your time and answer. Just think about their electron configuration and the periodic positions, and that's all. Very simple answer.
Yes.
Just think their electron
Teacher.
configuration. Yeah.
Yes, teacher. Configuration of nitrogen is 1s2, 2s2, 2p3.
Yeah.
And configuration of beryllium is 1s2, 2s2. Electron affinity means gaining an electron. When nitrogen gain an electron, it get destabilized. That means 2p4. So the energy needed to give an electron is high. So electron affinity value of nitrogen become a positive value. But when we consider about element like phosphorus, it becomes stabilized by gaining an electron. That means 3s2. So energy need is less. So nitrogen has positive values when compared to other elements. Likewise, in beryllium also, when gaining an electron, after gaining an electron, they become destabilized. So energy needed to provide is high. So the electron affinity value get positive.
Very good. We know the beryllium and nitrogen have relative stable configuration, right? And here the dominating factor is difficulty due to the electron-electron repulsion. So nitrogen and beryllium has high electronegative value. Very good. You answered well for my questions.
Yes, the students has answered the questions. Shavinda, will you explain this about your question? Just get 1 minute to explain.
Yes, sir. Now I asked them why chlorine has higher electron affinity compared to fluorine. Now they said the trend is downwards along the group. Electron affinity decreases, but chlorine compared with fluorine has a higher electron affinity. And I also gave them a clue to explain it according to the orbitals. Now the answer is fluorine it has a 2p orbital while chlorine has a 3p orbital. So the 2p orbital has a less radius compared to the 3p orbital. So in a 3p orbital, there's more space. So when an when an electron is added, now there are already electrons in the 2p atomic orbital of fluorine, so they give a more repulsion compared, because there's less space, they give a more affinity to the newly added electrons. Therefore, fluorine has a lesser electron affinity compared to chlorine, because the reason is because fluorine is in 2p atomic orbital and chlorine has a 3p atomic orbital. So it depends on the size of the atomic orbital. Yeah, that's a brief answer for my question. There can be other answers also, but I expected it relative to the space and the atomic orbitals. That's all. Thank you.
Okay, okay. Yes, very good. Now here your presentation session that's over, and the Viva session also we have finished now. Now we are moving to the marks session. So then we are going to reveal your final marks. Just wait. Okay. So you have done a wonderful presentation. So our examiners decided the final marks on your presentation, and then I'll be revealing the final marks for you, the average mark or the final mark. It is 20 out of 25. Okay, congratulations, you have taken 20 out of 25 for your group performance, this presentation, and you have done a wonderful work related to this. And then our examiners will comment on the session and then the things that you have to improve. Okay, so it is up to you, examiners.
Yes, thank you, Dulan sir. So the students, when you are giving your marks, according to the criteria we got, we considered several points like accuracy of slides, teamwork, communication and organization, power of presenting, voice and time management, Viva session or the Viva sessions, and finally creativity, overall quality and team skills. These are the 5 points we considered in your marking. So according to my marking schedule, actually you all did a good job. Your presenting skills is very good, and the presentation you make is really nice. But there are a few problems. I'll point out them. When you are presenting, something, you should understand and telling your points. That means understand and telling your points is very important rather than memorizing. I found like that some of you were telling some points with your memory. So it should be natural, right? The previous group, they did it naturally, so that's a simple fault I found in your group. And your presentation continued smoothly. You are not hurry, so I appreciate that. And it seems you all have done rehearsals also, so that's good. And the way you presenting, like the communication method, use communication method when presenting. One asks question and other was going to give the answer. So that method is really nice. And when you're making presentations, not for the online presentation, normally you should not use small font sizes, and also you should not use light font colors also. So that's not relative to this online type of presentation. When you are doing a live presentation, if there are so many crowd there, so all should see your presentation, and so be careful with that. And for this one, the online presentation, that's okay, because you all are looking your presentation, watching your presentation to a device, and when you're answering your questions, we found only one person answered for both questions. So everyone should involve in answering questions. And actually, this is your first experience in presenting online. So I really appreciate your effort. And it's better if you could make a video yourself and show us. Rather than downloading a video from internet. That's okay, that's a new thing, very good. Actually, this type of presentations we had in earlier years also, the live presentation. So this is a new experience to us also. So as a very young student, your team spirit is really good. And I really admire your effort. Good luck with your studies. Continue your presenting skills like this. Thank you, Dulan sir, also inviting me and giving me this chance to talk to you.
Okay, thank you very much, Sajida. For commenting on our students' progress, and then this is chance to the Shavinda. Okay, Shavinda, do it.
Okay, so first of all, I'd like to say your presentation was really good. I'd like to show up some doubts I saw in your presentation. The first thing was that questioning and answering session you all did. There was a girl asking the questions and the boy was answering, and you all only display the questions in the slides. But if it would be more, interesting if you all could have shown the answers too, rather than voice. With voice, you all should have displayed both the answers, so it's be more effective, you know. And the other thing was the organization of the presentation. It could have been more improved when compared to the last theme. Your presentation should be a bit more organized, but yeah, that's a manageable doubt. You all can improve it in your next sessions. And next thing was your presentation skills, and there were some errors, like someone's mic was unmuted, and we heard the sounds of the house and all. So you should be more careful when doing a presentation, because external sound will affect the presentation a lot.
Yes.
A lot uncomfortable when your mics are on and stuff, no? So that you should be more you should consider more when doing your next presentations. And also the colors of the slides should be more improved. Like, it's not very much attractive, but it's good because maybe because you all were really considering about this and you all did a good effort. Yeah, it's fine, but you can change it later. And answering the question, yeah, I thought you all will answer the question, but it's okay. There's only, and as madam said, there's only one student who was answering the questions, but you all would have collected more marks if the group, if more members were answering the question with like supporting each other. So now, according to the criteria, as madam mentioned, I gave points saying, according to this, according to accuracy of points and slides, you all were awarded 5 marks. And the teamwork, communication, and organization, I've given you 3 marks because there were some errors in your presentation. And then presentation skills, voice, speech, and time management. There were some doubts in your time management, and some of the language skills were, yeah, most of you all had language skill problems and communication problems. So I awarded 4 marks for it. And the Viva session, 3 marks because you all couldn't answer one question, and the same person was answering the rest of the 2 questions. Then creativity and overall quality, I awarded 4 marks. And finally, jumping onto your entertainment session, it was really entertaining, nice song. Thank you. And I'd also like to say, when I was in school, I remember we did the same type of presentation in school, and yeah, we got the same topic, periodic trends, and we have to do it using cardboards and those stuff. And you all got a chance to do it online. So it's a great chance for you all to improve according to the technology and according to the sources you all have. So it's a great opportunity. Thank you, sir, for inviting me, and you all did a great job. Thank you.
Yes, thank you, Dua. So I'm going to finish the session. I would like to thank our examiners and my dearest students for presenting here and then finishing this in a wonderful performance by you. So thank you very much for joining with us. So we are willing to get to the next team and the next performance. So I'm going to finish the session. Okay, thank you, Upani and your team. You have done a very good job. So it is wonderful, simply. Okay.
Yes, thank you.
Yeah, okay, thank you.